Hi guys, it's day 1-4 for geometry, which is a lesson all about parallel lines. It will be very helpful to have maybe some different colored either pens or pencils or a highlighter or something. Just be able to mark some things that are going on here. Right? Before we can jump into the types of angles we have to talk about. First thing, just a quick definition of what parallel lines are. So a lot of times we think, two lines that don't cross or don't intersect. And that's exactly what it is. So they are lines in the same plane that do not intersect. So like in this case, on the same flat surface that do not intersect. To show that symbolically that they're parallel, we put a little set of arrows on them that match. Right? So either single or double. And then the symbol for parallel. You can either do two vertical lines that are literally parallel lines, or maybe two slanted ones. I tend to do the slanted, but it doesn't actually matter. Some other things that we're going to need to talk about first, the idea of a transversal line. So it's a line that crosses the other two at two different points. So right here, this is the transversal line. Right? So I'm just going to kind of draw an arrow over to that. Right? The one other thing I should mention is that when we're going to talk about all these sets of angles, it helps to recognize what ones are on the interior of the parallel lines, which ones are on the exterior. So interior, we think of inside. So anything in between the two lines, like this piece of it, that would be considered interior. Anything on the far top or the far bottom, that would be considered the exterior. So out here is the exterior and at the bottom. All right, and that's going to change even if we change the orientation of the diagram. So if I was to turn it sideways, still the same relationship. All right, all the different angle pairs. I'm thinking you've probably heard these from Algebra 1, but it's fantastic to review them here. You have corresponding angles that are two angles that share, we say, the same relative position. So I think of it as, all right, I've got the transversal here. I have four angles down here, four angles at the top. If I were to isolate the top right angle of that intersection, its corresponding angle would also sit in the top right corner of the second intersection there. So you do get four pairs of corresponding angles. So both top right, you could say both top left over here. You could use, if you have a different color, feel free to use it. You can do both the bottom left or both the bottom right, all right? And if the lines are parallel, which is a lot of what we're going to be looking at here, then what we're going to note is the relationship between the angles. So given that we have parallel lines, here's kind of that proof notation. We're going to note that those corresponding angles are going to be congruent. Which means that they're equal. All right, the next set, alternate interior angles. All right, so when we said interior, think this area in between the lines, that's the interior. So it says two non-adjacent angles that lie on opposite sides of the transversal line inside the two lines. All right, sounds a little wordy, but if I go here, I have to go to the opposite side adjacent to the other parallel line. So down here, that's a pair of alternate interior angles. The second pair are the ones right next to them, but inside the lines. So there's just two pairs here. And we'd be able to make a very similar statement to last time. Parallel lines will give us congruent alternate interior angles. And now in the future, we will definitely abbreviate that verbiage because it's a lot to write there. Mm-hmm. All right, the next thing. I'm going to slide this up a little. Is alternate exterior angles. So exterior, we're on the outside of the parallel lines. So the opposite sides of the transversal line. So if I go top left, come all the way down to the bottom right. that would be an alternate exterior angle to that top one. And then I could make the same argument with these guys here and here. So there are two pairs. And we'd be able to, again, say that parallel lines imply that we're going to have congruent alternate exterior angles. So proofs is still a couple units away, but all sorts of stuff that's going to relate to when we get there. All right, this is the last one that's finally a little bit different. It's same side interior. So again, interior is this stuff in between the lines, and they have to be on the same side of the transversal. So it's either going to be this one on the left and then also this angle down here on the left, right? Or it could be the pair over here on the right. Now you're going to notice already I'm not marking them the same, and that's because they're not equal. It should be super evident that, you know, one here is acute, the other one is obtuse. They are not congruent to each other. But there is a relationship. So what we're going to say is parallel lines imply that supplement or same side interior angles are supplementary. And hopefully you remember from the other day, supplementary means that they're going to add up to 180 degrees. And again, there's two pairs of these guys. Whew. All right, that's a lot of stuff to write down. Now we want to actually use it. So when we get to the other side, we're going to do some stuff that's kind of quick, and then we're going to jump to some examples that take a little bit more work. We're going to set up some equations and solve. So let's flip on over to this page here. When it says list all the possible pairs for each one, right? It's just the idea that you're just doing some practice here. So the corresponding, this is the one where top right matches top right, bottom right matches bottom right, and so on. So angle 1 would match angle 5. And then you could go all the way around. Angle 2 and angle 6. Right? Angle 3 and angle 7. And then the last pair, angle 4 and angle 8. Now, I wrote that they're congruent just as a reminder, right? But that's only true if these lines are parallel to each other, right? Which is a lot of times what we're going to be looking at. Otherwise, you could just say angle 1 and angle 5, and that would be fine. All right, alternate interiors. We should have angle 3 and angle 5. And so you can put the congruent, or you could just list them like that, right? The other pair would be 4 and 6. All right, alternate exteriors. Angle 2, if that's top left, we match it down to bottom right. So angle 2 and angle 8, and then angle 1 and angle 7. And then I want you to fill in this last one, the same side interiors. What are the pairs there? Feel free to look back at that first page if you're not sure. And don't be surprised to see a little question about that guy. All right. So I would like to skip this next one. We'll save that maybe for class as a little recap tomorrow. Right? Let's jump right on over to the next page. So here's where the practice comes in. All right. It says for each example, state what type of angles there are and then find the desired angle. All right, so what I mean by state the type of angles, what angle pair? So when you're looking at this one, it's top right and top right. That's an example of corresponding angles. So I hope you were already thinking it before I said it, right? And corresponding angles means that they're going to be congruent. That's the relationship. And when we say congruent, that's essentially the same as saying they are going to be equal measure. So we can set up an equation to make 2x minus 45 equal 2x plus 30. Again, only true if they're parallel. And I can't remember if on your packet, if it shows them as parallel, but it should. So in case it doesn't, go ahead and put in those little arrows to indicate, yeah, they're supposed to be parallel lines. Right? Then we can solve it. So we can subtract x over. At the same time, I'm going to add the 45. And so I end up with x equals 75 right here. And then the final part of that is it asks you, find the measure of angle DEF. So when you trace that out, DEF, that's this guy right here. So measure of angle DEF is equal to x plus 30. So 75 plus 30, it should be 105 degrees. That's my final answer for that one. Let's take a look at number 2 right next to it. So find the measure of angle ABC. So ultimately, we're going to want this guy here. But take a look at what is labeled. We've got angles that are both on the interior and they're both on the same side of the transversal. So it literally means we've got same side interior angles. See if that helps a little. Just turn on the light. And now, if you look back to the first page, they are not congruent. They are supplementary, right? So that means they're going to add up to 180. That's the relationship. So let's create an equation that represents that. So 2x minus 7 plus 3x plus 17 equals 180 degrees. Keep going. Combine those x's, we get 5x. Add together the constants, we get plus 10. And then we can keep on going. So subtract that 10 over. And then we'll divide by 5. Hopefully you've got a calculator somewhere nearby. 170 divided by 5 should come out to be 34. And then last thing, plug back in to get the measure of that angle. So I've got just enough space right here. The measure of angle ABC is equal to 2 times x minus 7. So this is going to be 68 minus 7, or 61 degrees. All right. The 2 beneath it, numbers 3 and 4, I think I would like to save those for class tomorrow, but something I want you to kind of take note of is that they each have x squared in them and an x squared over here. So that means that you're going to be doing a little factoring to be able to solve. So write yourself this little note here that you're going to have to factor to be able to solve those last ones. If we flip on over to the very last page, there's some more practice up top. It's just saying, given that you know the measure of one, do you know the measure of the others? Because we can do this one so quickly, let's do it. So if angle 1 is 145 degrees, that means immediately so is that measure of its corresponding angles, of its alternate interior angle, and in this case of angle 3, that's its vertical angle. So that should be 145 degrees. The corresponding angle over here, 1 and 4, that's 145. From 1 to 2, that's its alternate exterior. So all of those end up being equivalent to it. The only exception to that would be, 5 right here. And you can look at it a number of different ways, but the fact that, this creates a straight line right here, together those have to be 180. So that's another way that we see that supplementary relationship. So 180 minus 145, that should leave us with 35 degrees. And so you can label in the picture or you can label it over here. Either one is perfectly fine. All right. So test your skills. What kind of angles are 1 and 2? Those should be alternate exterior. And you can abbreviate a little as long as it makes sense to you. 1 and 4, corresponding. 3 and 4, alternate interiors. 3 and 5, same side interior. And then what kind of angles are 1 and 3? Those are vertical. And it's CAL angles. All right. The last ones, when it just says determine if the lines are parallel or not, it's just saying based on the information. So if those alternate interior angles are equal, then yes, they are absolutely parallel lines. Whereas here, they're showing you a pair of corresponding angles that are not equal to each other. This one's different than that one. So this would be not parallel. And you can simply show that with a little slash through it like that. All right. When it says explain why, right, it would simply just be the corresponding angles are not congruent. You can say equal or congruent. Doesn't matter. All right, we're going to call it quits there. We'll pick back up tomorrow and we'll do some practice with the ones that we missed. Don't forget to answer that question back in the Google Classroom when you're done watching this video.